I would like to talk about nature observations. First of all, I would like to present project Kiwi, which is related to remote laboratory and nature observations. And then to talk just a bit about radio astronomy, which is different kind of nature observation, different in different scale. And at the end, some facts about ultra-high definition technology, just to make an update to Okung's slides. Okay, so first of all, Kiwi project for nature observations. Kiwi stands for Knowledge, Infrastructure, Workflows, and Instrumentation, and is a framework for building remote laboratory, remote instrumentation system. The platform is also either hardware and software. Hardware is a set of sensors like cameras, temperature, and other, for example, water flow sensors. And the software part is for managing and controlling everything. Software is based on some unique protocols and standards just for controlling all the laboratory. The motivation was to use various types of cameras for different appliances. For example, small compact camera for very small box for observations, for excellent quality and zooming or macro scale, better photo cameras, and for recording fast movement or tracking objects, they use HD cameras, professional cameras. So you can see the observation kit, let's say, the observation platform, which is a photo camera with some controlling software, and it's basic set for automated nature observations. There is remote controlled camera for making high resolution photos in ultra high definition. There was also some development of pan tilt zoom platform for rotating and moving the camera, the whole set of for nature observations, because there were some limitations of existing PTZ pan tilt zoom platforms. For example, lower resolution of movement, or problems in carrying heavy equipment such as computer cameras and so on, and of course different appliances. Our colleagues had some specialized appliances for their hardware, so it was necessary to build from scratch from some ready elements, but from scratch pan tilt zoom platform. You can see the content of the box. It's a photo camera with lenses. There is also a heater, because it's usually the use is usually outside, so in different weather conditions. There need to be controlling computers, some converters, controllers, and of course power supply. The exemplary deployment is tracking animals on. There is a bridge. There are some bridges in national park. There is highway, and there are some bridges on top of the highway for animals to let them move from one side of the highway into another one. So the national park would like to track some animals and their behavior. So the requirement was to cover quite large area of the bridge, about 30 meters to 20 meters. So ultra high definition was necessary. It must have been operational for 24 hours per day and 7 days per week, so all the time, and also to provide night, also to be operational during the night. So there are some infrared lights integrated. Of course, all atmosphere conditions and security, because it's let's say publicly available, not only for animals. So you can see the box with the camera, some views from the bridge. It's the integrated box, and some effects of tracking animals all during the night. So they have quite many interesting effects of the system, and such boxes are in several places in the national park. But that is not only appliance of Kiwi system. Another one is fire monitoring recognition. There is a tower, observation tower also in national park near Poznań, and firemen and the authorities of national parks use the camera and the platform for tracking, for monitoring fires or some unexpected events in the forest. Of course, there is also educational use of the platform at schools or universities, just to provide some tools for students for making some projects. And this Kiwi platform can also be used in security monitoring, which is obvious, of course. You can see some more photos of different appliances, boxes, integrated boxes. Okay, and different view of nature observations is radio astronomy. There is no cameras, in fact, because it's a network in the VLBI project. The VLBI project is a, let's say, network of radio telescopes, which makes one big radio telescope system. So as you can see on the picture, for instance, three radio telescopes, 3 distant radio telescopes can make one big, can act as one big radio telescope, 1,000 kilometers. So the Polish deployment is in Toruń, and they can observe the space in radio frequencies in very high resolution. And what is quite interesting, the RadioNet is also TNA, so it's like Visionaire, but for radio telescopes. So it's quite interesting. You can see some visualizations of the data. So it's quite interesting appliance of nature observations, but in large scale. Just to finalize, I would like to give some data about ultra high definition. As Okung said, there are various standards and various bandwidths related to the actual resolution. But what is quite important now, there are television standards for ultra high definition. There is ultra high definition 1 and 2. One is more or less 4K, but 4K and 8K are related to digital cinema, and ultra high definition is rather for television. So ultra high definition 1 standard is about 8.3 megapixel. You can see the resolutions of them. Ultra high definition 2 is related to 8K, is 33 megapixels. So what is important, and I mentioned this before, photo cameras available on the market are already ultra high definition or more, because for instance Canon EOS 7D, which is consumer photo camera, is 18 megapixels. But usually photo cameras have poor frame per second, right? Up to 8, up to 10. So in case of requirement of fluent movement or making very fluent transmission from some places, we use 4K cameras. And what is also interesting, there are many new cameras available on the market in 2012, and some are also introduced in 2013. Of course, the ultra high definition gives us more. We can see more details, as you can see in the, let's say, the comparison between standard definition, which is more or less PAL or NTSC, HD, full HD, and 4K. We can see a lot of details in 4K or ultra high definition 1. Of course, in ultra high definition 2 we can see much more, but it's very difficult to see 8K because of the lack of such installations. And 4K or ultra high definition gives us also wider perspective. We can show more. Opung already mentioned those numbers, but just to finalize, we need really for storage ultra high definition, we need really much disk space and network. And for 3D, it's usually double. Those numbers are doubled. So we usually use JPEG 2000 for digital cinema or for specialized appliances. But there is also H.264, which is MPEG-4, and the standards tell that it's about 200 to 700 megabits per second for 4K. And there is new standard introduced, H.265, which is high efficiency video codec. It's new standard in 2013. It's about up to 100 megabits per second for 4K, which is less than JPEG 2000 and of course less than uncompressed. And for 3D, of course, you need to double those numbers. Network requirements for 8K uncompressed, we need 100 gigabit link, which is quite much still. And as I mentioned, there are some photo cameras on the market. The problem is the lack of live interface. But there are also some new models. Just to mention, Sony F55, which is professional broadcasting 4K camera with SDI links, and it's quite interesting. The price is quite much, but less than other cameras. And another quite fine camera is JVC. It's consumer or prosumer segment, but very cheap, about 7 $6,000, 6,000 euros. So it's very interesting, and we already did transmission from Poznan to Amsterdam using this camera. So it was really fine. The picture was very nice. At the end, I would like just to mention that because of the lack of cameras, good cameras for scientific use and for nature observations, we started the project of building 4K mini camera in PSNC. The cost of the camera should be less than €1,000, and of course live output, live uncompressed output is the most important requirement. The camera will be integrated with Kiwi platform, of course, and but we also can imagine other appliances such as video conferencing, perspective glasses, for instance, in medicine or virtual reality, multi-view system, holographic transmissions, also as a multi-view application, and other like high-resolution microscope, for example. It's also a kind of nature observation.
What will be the good infrastructure to be sure that, for example, that we can connect a nature observation from a boat, a nature observation from elsewhere in the world? Can we imagine to have this kind of infrastructure, or do we have to connect them in order to provide the visualization from Europe in any location through the streaming solutions of the giant network, or with 4K or 8K display in PSNC? What will be the good process to get this? If we want to observe the bottom of the sea, what we'll do in order to get the results of the observation from our seat in PSNC?
Yeah, in case of this this highway bridge, there was no problem because there is a fiber optic network, fiber optic link, because there is an infrastructure, also network infrastructure along the highway, so it's no problem. But you asked about the for example sea observation or something like this. On IBC first, I saw the NHK demonstration of 8K. It was a couple of years ago, but they streamed live. There was a live transmission from UK, as far as I remember, or from Japan, from Japan to Amsterdam, and they use satellite link about 150 megabits per second for 8K transmission. So it was, of course, quite much, but it is possible to transmit via satellite such resolution in MPEG-4, for example, or MPEG or H.265. It is possible, and of course, from the deep sea, let's say, we need to have a cable or fiber cable down to the sea, because I don't think the radio transmission from lab or boat, submarine is not possible. But of course there might be a fiber cable.
The process to connect the satellite networks and things like that, how can we?
The cost? No, I don't know, but it was
because I do not know, but the process to get that. What are the good infrastructure to contact? If the demo in Amsterdam was done by NHK, which is the main Japanese television. So I suppose they have everything on satellite and so on. So it's probably not a problem for them. I don't know if there are some
let's say, satellite for scientific use or for research. Perhaps yes, but I don't know person to contact. But we can ask our colleagues. Maybe they know something.
If a case occurs, it will be interesting to, but it is not necessary to explore that before the case is occurring. But
yeah, if we have a user from deep sea, we will investigate this.
Okay, it should be interesting to have this kind of projects also, and to have a 3D stereoscopic visualization of deep sea from your in PSNC or in Bristol, why not? Will be very impressive application for visionary.
Yeah, and I hope until, I don't know, in a couple of months, maybe until, well, for sure until the end of this year, if we don't have any special problems, we should have the mini 4K camera for scientific use. It will be quite small, about 7 centimeters, 6-7 centimeters wide. So we'll be able also to send the camera to our users for just to provide the 4K data to our 4K stream to our visualization room.
About your camera, it's just €1,000, which is much more less than.
We don't have the price. It's less than €1,000 is the cost of elements. So I don't know the price because there is, well, we have some prototypes, as you can see. It's real prototype on the screen. It's the prototype of HD camera now, because but the sensor is already 4K capable, but we have to try all things. Well, it's easier to test in HD environment, but then we can extend this to 4K, and I hope this will happen until the end of this year. But I don't know the price at the end, because it's,
even if it is €2 by the end of a process, because you have extra cost, I do not know. It's very impressive to get this cost respect to what you presented before. So what will be the main difference in quality between yours and the GVC or the other ones? Is it just the electronics who is cheaper now?
Comparing to the view from the camera, the movie camera, let's say, to photo camera, you can see the difference. If you just make a photo from photo camera, it's better quality than movie camera. But usually photo camera cannot take more than 8 frames per second, and usually it's in lower resolution or in HD. So there are different kind of appliances, different kind of use. If you need fluent movement, then you and can have worse quality than just a photo, you should use such cameras as we are developing. If you would like to have still images, a set of still images, but better quality or more, yeah, in better resolution, because photo cameras are, as I said, it's for instance, the Canon camera is 18 megapixels, which is, I don't know, 6-7K.
Okay, so it will be the rates and things like that, which will be less important on your camera. Thank you very much.
I just had a very quick technical question about the mini camera, because I saw that you are implementing 4 3G SDI ports. Why 4?
Well, now it's a standard for 4K to use just 4 3G SDI links because each can carry HD or 2K resolution, let's say. There is planned 10G SDI. So for consumer, on consumer market, there are some equipment using one HDMI link, but it's it's less than it could be. I mean,
yeah.
It's not. Well, you need more than just one link. In fact,
But
so
with the form, what you're doing is, are you segmenting the image to send it through through multiple links?
Yeah, it's well, we will do this in logic. In chips, it's FPGA chip, and it will be able to divide the image from the camera into several links. And of course, as I said, now is a de facto standard, let's say, because all professional 4K equipment is able to take 4 links independently. So, for example, we have Sony projector, which has 4 dual links, in fact, which is more or less the same as 3G. So we even have 8 links for 4K. It's a technical problem, of course, because you have a lot of cables, but just to provide the best quality and the best resolution, you need to use 4 3G SDI links.